Let's find the velocity and acceleration of the particle given that the distance function s of t equals under the root of t squared minus pi. The distance is measured in feet and time is measured in seconds. So first I'm going to write down the velocity function v of t, and this equals the derivative of the distance function, that is s prime of t. So let's see how to find out the derivative of this expression. So here we have to apply the chain rule. Considering the outer function is a square root function, so let's say that we put this outer function as square root function. This is outer function. Write down this as outer function. And then the inner function is the t squared minus pi. This is inner or inside function. So when you apply the chain rule, we have to first to find the derivative of the outer function. Since it is a square root function, the derivative of a square root function is 2 times of 1 over 2 times of this square root. And then we have to multiply with the derivative of the inside function. So let's do it over here. So I'm going to write down this v of t, and this equals first I find the derivative of the outer function at the inside part. So I'm going to put this as, since the outer function is a square root function, I put this as 1 by 2 times of square root of at the inside function. So we have to put this inside part as it is, and then multiply with the derivative of the inside function. That is, we have to find the derivative of the inside function, that is t squared minus pi. Its derivative is 2t, and the constant is 0. So basically the derivative of t squared minus pi is 2t. So I put 2t here. Let's simplify this. We see that we can cancel this 2 in the numerator and denominator, and so basically the velocity function, this reduces to t over t squared minus pi. This is under the root. And since we want to find the velocity at t equal to 3 second, we plug in t equal to 3 into the velocity function. So therefore we get v of 3, and this equals 3 divided by, replace t by 3. This is 3 squared minus 5 under the root. So this equals 3 divided by 3 square is 9. So it is 9 minus 5 under the root. So this gives us 3 over 9 minus 5 is 4. So it is under the root 4. Square root of 4 is 2. So we put 3 by 2. Or else this is, in fact, it is exactly equal to 1.5. 3 divided by 2 is 1.5. And we put the unit as feet per second. So this is the unit of velocity. So we have determined that velocity equals 1.5 feet per second at the time t equal to 3 seconds. We now determine the acceleration of the particle at t equals 3 seconds. So acceleration is given by the rate of change of velocity. So we write down a of t, and this equals v prime of t. So let's find the derivative of the velocity function, that is t by under the root of t squared minus 5. We have to find its derivative. So this derivative gives acceleration function. We can find this derivative using the quotient rule. So when we use the quotient rule, we put the denominator term as it is, and then multiply with the derivative of the numerator expression. The numerator expression is t, so derivative of t with respect to t is 1, minus, we put the numerator expression as it is, multiply with the derivative of t squared minus 5. This is under the root. So let's do it here. In fact, we have done this already when finding the derivative of when finding the velocity function. So basically this gives 1 over 2 times of root of t square minus pi when we consider the outer function as square root function. So square root derivative of square root function is 1 over 2 times of square root function, and multiply with derivative of t square minus pi, which is 2t minus pi. So this gets reduced to t over under the root of t squared minus pi. So I'm going to put it here, that is t over t squared minus pi. This is the derivative of under the root of t squared minus pi. And this all over, according to the quotient rule, we have to square the denominator term, which is t squared minus pi, under the root quantity square. So let's evaluate or simplify this. So a of t, this gives t squared minus 5 under the root 1 times is t squared minus 5. And then this becomes t times t is t square divided by under the root of t squared minus 5. And this is all over. We square a square root, so the square root will get cancelled. That is, the square root and this square term will get cancelled. So finally, we are left with t squared minus 5. Since we want to find the acceleration at t equal to 3 seconds, we will not have to simplify this. Instead, we plug in t equal to 3 into the acceleration function to determine the corresponding acceleration. So we get a of 3, and this equals 3 squared minus 5 under the root minus of 3 squared divided by 3 squared minus 5 under the root, and this is all over 3 squared minus 5. So let's evaluate this. The first term is 3 squared minus 5, which is 9 minus 5, and this equals under the root 4, which is 2, minus 3 square is 9, divided by the same expression, so it is 9 by 2, and this is all over 3 square is 9, so 9 minus 5 is 4, so we put 4 here. Let's evaluate this. This is 2 minus 9 by 2. This is exactly 4.5. So it is 2 minus 4.5 divided by 4. We calculate this, and this gives negative 2.5 over 4. And so if we plug this into the calculator, we get negative 0.625, and the unit is feet per second square. So this is the acceleration. This is the acceleration of the particle at t equals 3 seconds.